Good afternoon to everyone. My name is Bhargav HK, BITES Bengaluru. I would like to welcome today's expert, Prasad Chitta, and all the participants to BITES Expert Series. Today's topic is artificial intelligence in decision making. I would like to introduce today's expert, Prasad Chitta. Prasad Chitta is a lead with BFSI Analytics and Insights, Tata Consultancy Services Limited. Prasad has a Master of Science in Computer Science degree from Alagappa University, Karaikudi, Tamil Nadu. Prasad currently works as Decision Intelligence and MLOP's practice lead with the BFSI Analytics and Insights. For the past 8 years, his primary focus areas in the machine learning and artificial intelligence. In his 30 plus years of overall industry experience, Prasad worked with ISRO, TCS, Oracle Corporation, and IBM Limited, IBM India Private Limited in various software services and implementation, product development, and technology management roles. Apart from work, Prasad enjoys blogging on technology and Indian philosophy and Advait Vedanta. On the behalf of participants and BITES team, once again I welcome Prasad Chitta sir. I request Prasad Chitta to continue the session. And I want to take later moment. I would also like invite a special invitee, Srinivasa Ramanujam sir, TCS. Thank you, sir. I request Prasad Chitta sir to continue the session.
Thank you, Bhargav sir. So we can start in the session. Actually, I think still participants are joining. So good afternoon, everybody. I hope everybody is joining from India. So the session or the topic for today is artificial intelligence in decision making. So the way we touch upon this subject is we will touch a bit of decisioning, the complexity of decision making, and then how artificial intelligence can be utilized. So typically when people are looking at artificial intelligence today, AI or machine learning, there is a lot of hype, but all that hype, it can help some amount, but the focus will be how we can use it in really in business decision making. That is what it is. The session will be, once the session is over, we will be taking some questions. So you can note your questions and ask the questions in the question answer time. Okay. So what is a decision? So what is a decision? Typically anything in the business, anything when we are doing, we take decisions, lot of decisions, what to do, what to eat for the breakfast. Everything is a decision basically. But when this decision has to be taken in a business setting, that is where there is a structured mechanism, structured method is required. So the decision need to be, we have to be answerable to someone, because when I take a decision, if somebody gives me a loan application, I wanted to take a loan for something, then there should be a standard process which is available to take the decision. We will calculate a score. So that is the standard industry practice, where we calculate what is the credit worthiness of the score. And there is a threshold set saying that if the score comes above 700, I will give the loan, or if it is not coming to the 700, I will deny them. So how this 700 is arrived at is the box which is there here in evaluating the credit worthiness, right? So the decision is nothing but a point in a process where something has to happen, some evaluation has to happen, something need to be taken. The process changes its path from a path to other path based on these whatever decisions a business user is making. So how many, the core component of, okay, calculating the score, once the score is there, we have a rule defined on top of it. So this is the second concept. There is a rule defined or a policy defined to say that if the score is above something, we will grant the loan. If the score is below something, we will deny the loan. But calculating this score,
Prasad sir, we are unable to hear you. Is it only for me or for all the participants?
Not able to hear, madam.
Thank you, sir. I think some internet problems, sir will come in a minute. Thanks for your patience. Let's please hold on.
Yeah, you go ahead, sir. Not audible.
Sir, you are on mute. You should unmute yourself, sir.
okay. So I don't know. I think there is a disconnect for at least a minute or so. So we are talking about the decision complexities around the decision making, how to evaluate this credit scoring. So what are all there are various factors. The income is one of the factors, outflows of the cash. So the credit worthiness can be based on various parameters and factors of either that company or the person, individual who is approaching for the loan. So based on the complexity of it, there is a weightage given. So there are people who are experts in looking at the applications, looking at all these forms and say that, okay, this is credit worthy, I can grant the loan here, right? So human intuition can be one way of doing it. Simple business rules. I wanted to say, if you have 5,000 rupees income every month, I can grant up to 50,000 rupees loan. Okay, some kind of such a rule can be set up. So business rules, various complex weighted business rules. There can be various ways of taking this decision. Okay, but the complexity of the decision making is much more significantly increases with the scenarios become these factors. If it is just a loan application processing, it can be considered as a simple ordered framework, because we know when the application comes, there are several pieces of information we take, and the dependencies of those application is all available. So it is a very orderly system. We have understood the system, but there are various other scenarios. If we take, there can be complicated scenarios where that causal analysis, what happens to that target, or what happens to the system if we change some parameter, that definition is not understood very clearly. In complex systems, so basically that is much more difficult. And so depending on the type of the system which we are talking about, the decision making, the cause and effect of the decision making, what is causing which decision to be made, what factors are used in this decision making, changes. Okay, so there are frameworks. This is called Sinafan framework for the decision making. It has been it is one of the standard frameworks that is available, which gives the sense making of various ways of how to respond when the response will happen. Okay, you sense or you observe the factors, you categorize the factors and respond if it is a simple. You have to sense, you have to analyze, and then finally respond. You have to probe in the complex system. Sensing becomes very difficult. You have to first probe to get the parameters, probe, sense, and respond. And similarly, act, sense, and respond. So you have to first act in a chaotic system. You don't know what is related to what at all. So it will be an experimental model. So this in these various scenarios, various ways of doing this decisioning is there. So what we have discussed until now is about the decisioning. It is a simple decisioning process to a very complex decision process that may be involved in business settings. Okay. So all these decisions predominantly are taken by the human players. People are in the waiting room. Okay. So I think right. So can machines, so let us try and see, can machines make decisions? So what are all machines? So machines can be programmed to make decisions. So machines are faster in processing. If you supply all the required parameters, machines will process the parameters faster and give the outcome. Give the outcome, whatever it is programmed to give that outcome, they will be able to. So can they make decisions? May not be. So normally the machines will
Prasad sir, again we are not able to hear you.
Yes, sir. You go ahead, sir.
not sure why this is disconnecting. I don't know where the problem is. Yeah. So let us get back onto this discussion of machines taking the decisions. How we can how the human intelligence or a human agent who is taking decisions can be augmented with artificial intelligence. That is the next part of the discussion. So machines can be programmed to take decisions. So whatever a program, however we instruct a machine to do that, take a decision, compute a score, and use the applied rules, complex rules, simple rules, or machine learning based predictions to take the decisions. Hard coded rules is one way of machines making decisions. But as we move into this artificial intelligence, layer of artificial intelligence, where we are trying to do it, three branches of AI that are developing, which are contributing greatly to decision making agents, creating decision making agents within the businesses. So the first thing, as I said, adaptive AI. So artificial intelligence, the moment we talk about artificial intelligence, what we get to know is models. So there is data, we get a lot of data, samples, examples, basically it can be pictures, it can be video, audio, text, it can be structured data, anything. And the model is created by running a training on that example data for either a supervised learning to predict a outcome, X or Y, a score or a category and stuff like that, or an unsupervised learning of automatically grouping them into the segments, groups, whatever it is. But this AI in these models, typical models, it cannot take any decision. It can only give the prediction, leave it. Because decisions are complex. We have to consider multiple factors, group them together. And contextually, things will change. Contextually, dynamically, things, the factors which we take. So the same credit decisioning, if we take, if there are two applicants and joined together, they are earning a lakh of rupees per month. This is different from there is only one applicant who is earning 5 lakhs a month, right? So their earnings are good, or they are earning, but already they are paying several EMIs. Already the outgo is to the nearly to the income of the individual. There is no additional credit that is available. There is, you cannot, they will not be able to repay the additional amount. So what happens in these all these multiple scenarios, once you summarize these factors, so if you say I wanted to consider this simple factor, this more dynamic factor, all these factors into consideration before I take the decision, that is where the AI need to be more adaptive. So given an input scenario, this input scenario is having more context, the additional context, how an artificial intelligence agent can understand this new scenario, create a newer understanding, and provide the decision, provide at least help to take the decision. So that is where the concept of or the field of adaptive AI is emerging. So that is one part of the AI. The second one, I think now everybody is behind, is the generative AI. So generative AI, the artificial intelligence type of these models and systems, they will generate a new creative type of outcome. So you will prompt for something, and the generated, the chat GPT is the example. You prompt for something, you will get the output based on all the language or all the previous pictures it has seen. it will do. So there are three different techniques that do the generative, that is adversarial networks, generative adversarial networks, GANs. They are one first thing. There are other diffusion models in the middle. And finally, we have got into something like transform, bidirectional transformers. But it started with BERT and all other multiple transformer models, generative transformer models have come. So the advantage with these models is they can generate new scenarios. They can create newer looking representations of the data, and they will be able to provide several new things. But the problem with generative AI is there is no way you can validate the outcome given by the generative AI is right or wrong. For example, recently somebody has used a ChatGPT kind of generative algorithm, one of the lawyer in US, to create a case. So generative AI created all the case related things. It has quoted some previous examples saying that, okay, in this case number ABCD, such and such verdict has been given, blah, blah, blah. So I put my case saying that this is how my client should be awarded the compensation or whatever it is. So it has created a 10-page long case note. And lawyer has gone ahead and submitted this to the court. And in the court, judge or whatever, the court, when they are seeing whatever 10 cases it has quoted, the case numbers are there. But in that case verdict, it was never there that whatever is this generative AI has generated. So it has just cooked up what it has created. So what has happened? Generative AI can be creative. It can create things to speed up the process or whatever it is. But the validation of that will be very difficult because there is no truth value to compare with. So it is not like traditional AI. So what we have to kind of bring this adaptive AI and generative AI together using something called responsible AI. That is where the practices of responsibly using artificial intelligence, responsibly creating artificial intelligence systems comes into the picture. It need to be, there are several basic principles, explainability, accountability. Who is creating this artificial intelligence agent and who is using it? And all these people who are creating, people who are using it, people who are in various roles of artificial intelligence systems creation, they have to always take the responsible. They have to take, I am responsible for making good to the society with this artificial intelligence. So those principles need to be adapted, and there are a set of guidelines and frameworks, methodologies that are evolving, which is known as the responsible AI as one of the threats. So basically, if we wanted to use artificial intelligence, it should be adaptive. It should have the capability to correct itself to the context or adapt itself to the context. And we can use generative. So to generative AI to create new scenarios, understand the scenario in much more better way, probabilistically analyze what if, and this kind of things can be done using generative AI much faster than traditional artificial intelligence and traditional computing. But they have to be based on the basis of responsible AI. Okay. So now, until now, we have covered the overall process of decision making, why a structured piece of decision making is required, how AI can be used, artificial intelligence can be used by the machines or trained by humans, put into the machines as systems, machine learning systems and AI systems that are adaptable, that can generate, that is responsible. And this making the better decision. So how it all starts is from the data. So you start with the data. From the data, you generate some patterns and insights. Then you understand these are all the factors that are related. So this is known as known connections between the decision factors. So again, going back to our credit decisioning example, which we started with, the income, the expenditure, the quality of expenditure, the quality of income, how regular the income is, etc., etc. These various parameters that feed into the decision, and also the demographics of the people, the macroeconomic situation of that particular industry. All these different things get into the decision making to a of the thing. Then an action is either approve, deny, something has happened. Then based on these actions, the outcomes will come. The loan will be given. Then loan repayment has to happen slowly every month, and finally loan gets closed. In the period, the company which has provided the loan, they will earn some amount of money. That is the outcome finally. So in each stage, right from the data collection to the insights generation. So in this year, we have processed 100,000 loan applications or 100,000 mortgage applications, home loan applications, personal loan applications, different types of loans are at. From there, we have generated some insights. We have had some non-performing assets. People have not paid, so we were not able to recover some money. We were able to get some money. Some people have pre-closed their loans, so our expected outcome has not come. So all these different things, information can feed back into this whole process and make it whole adaptive. So basically, we need to, in the decision ecosystem, at each stage, there is a feedback that comes in. And at each stage, the feedback should be processed by the decision-making agent. So this decision-making agent can be a human, means which is natural intelligence, or it can be a machine, or a combination of human and machine together, right? So the combination is what really which helps. So that is where we are trying to go, which is human has certain abilities, machines have certain abilities in this process of decision making, making better decisions. And how do we bring the best of the worlds together for the benefit of businesses and overall for the society? That is the point. So to achieve that, what are all the different things which we have? We spoke about the data and features. So what is raw data? Raw data says such and such applicant has applied for a loan with bank A. The same applicant has gone and applied for loan at bank B. Whatever. So you would have applied for the loan. You would have taken different types of loans at different. These are all the pieces of data. But what we want to make the decisions or create the models is what is the monthly income of this individual or the company? What is the cash flow of the given company? So these things are called features. So how do we derive these features from the raw data that is available? That process is known as feature engineering. So you create features, then you give these features, you create a set of machine learning models. These models can be as simple as a regression model, which is going to give a regression output, or they can be decision trees, random forests to deep learning models, bidirectional transformers, whatever they are doing either forecasting, they are learning to perform a task, they are learning to estimate something. They can be Bayesian models that can give the probabilities of events happening. So those are all the models. But models alone cannot do things, right? They cannot behave, they cannot process the feedback, they cannot be adaptable. This is where we actually have the concept, the core concept of decision platforms is something called decision agent. So we wanted to create a decisioning agent decisioning agent should have intelligence. Intelligence has three components. What is the three components? Should be able to understand the context, think or formulate, and learn from the feedback while taking this decision. So understand, think, and learn are the three core components of the intelligence. So the decision model, whichever the model which we are creating, the features that are being assembled, this is the understanding. They create a particular picture, or they create a particular vector. In technical terms, they are called the knowledge vectors or the whatever feature vectors. So what we have formulated, what we have understood from the presented scenario, which is data. Data can be a picture, but the processing need to happen. Somebody has to understand what is the background of the picture, what different segments are there, what is different areas, what shapes, sizes they are, and objects need to be detected, the interrelationship need to be detected. So all these things is called understanding. Even our understanding, when we see something, we do the same. Then we have to relate with our past knowledge. The thinking process will come in. Then what happened in a similar scenario in earlier experience, that need to be brought in together. Then finally, we also need to learn from this new. How this presented current scenario is different from everything that is known in the past. And what can be done differently, given this scenario is looking half like, means 50% like one known scenario, 40% like another known scenario, and 10% not understood. Then how do we assemble our decision? In scenario one, what has been done? Scenario two, what has been done? And in unknown scenario, what we should do. So that is the part of the learning. And also when needed, we should be able to take the feedback from a human player, a human decision agent. And finally, this decisioning has to happen in a network, not an individual. Not so in each individual decision agent can only see and perform a task. But in business, you may have to take multiple related decisions. So if I wanted to increase some budget, so I am going to pump more money into it. That means I have to recruit. So I am going to say, okay, I will allocate more money for resources. I wanted to recruit more people for achieving my target. So how do I achieve? Just by allocating more resources are not sufficient. You have to go to the HR function and actually look for, advertise for those people, recruit them and make them work, right? So there is a network of different decisions. Can I recruit this person? So if I wanted to recruit somebody at some cost per month, will I get such a resource, such a person to recruit? Or will I be able to employ an artificial agent to do that work? Or can I get a service from somebody else? So there may be various things, various scenarios that may emerge. So this is an example of how these decisions will interrelate within a given business scenario. That's why a decision agent alone cannot perform all the time. This decision agent need to be connected with other decision agents and form a network to make these decisions and learn from each other. So those are the different components that are needed in bringing in artificial intelligence, these models as agents, agents as decision network, and deploying them for a business. Okay. So the key thing is, this is again a eternal question. Can machines or the artificial agents, can they have something very similar to humans? Humans have a very interesting feature called unpredictability. Okay, so you can never predict a human behavior. Means majority of the social, like the what you call that, trends can be predicted. But when we go to a single individual, when we are taking some important decision, how a personal decision will be made it depends on the factors that cannot be quantified by the machines to understand. Even probabilistically not known. There are factors which are beyond the comprehension. Why somebody take some decision, that is called empathy, or the self-awareness, or the gut feel which comes to the human agents, that will never be able to be infused. We will not be able to infuse that into machines. So with that, like we should go to the next one. So this is the kind of the final framework that, okay, it is a generalized framework of bringing this artificial agent, artificial decision agents together in a complex scenario, decision-making scenario. So on the right-hand side of the yellow color, which one is there? That is known as a context, business context, which is under control of the decision maker. So if I am the decision maker, I come from finance department. So I will have some flexibility that I can change some of the cash flows. So whether I will keep the cash or I invest my money into a share market or I buy gold and keep it, or what type of investment I keep it and keep my assets. There are different levels of liquidity. If I have money in the share market, I can immediately take it out. The same thing if I put it into a real estate or a site or a house, if I want to convert that back into the money, there is a long process of selling this. This asset will be there, or otherwise I have to hypothecate this asset and get a loan out of it. So there are various complex things I may have to do if I have to manage finances for a company. So there can be different levels of investments. There is immediate daily cash flow, how much payments I have to make today, how much receivables I am getting, how much I will get tomorrow, how much I will get this month end, how much of salaries I should pay, how much of interest I should pay. If somebody comes and suddenly closes their deposit, how much I should pay it back or whatever it is. So I may have some parameters that are in my context. But for the things, if I want to keep myself liquid and I wanted to keep sufficient funds, there are parameters what RBI is going to take. Their policy, which is not in my control, right? That is the external context. And similarly, within my own organization, my advertisement department, who is going and saying that I will give you a two-wheeler loan or a four-wheeler loan, some campaign they are doing, they are going and doing everywhere, they are putting hoardings and stuff like that. That is not in my control, but I am aware of it. Something is happening because there is a campaign like that is happening. I may get more loan applications for four-wheeler. I may get more such applications. So that is where I may have to go. So there are three contexts, which is a context which I can influence. I have my own influence on it. A context that is influencing my context, but not in my control, even though it is within my company or within the proximity of me. And there is an external context, which is there can be a war coming out, a pandemic coming in. We don't know the parameters that influence our decision making or running this business. Completely external parameters. But we can observe them. We can observe the signs of them. Okay, there is something is happening. There is a recession. People don't want to buy. People don't want to spend so much money, etc. That kind of thing. We can sense. We can get those parameters. We can use it in the model. You can use it in this decision-making network. But we will not have any control over it. And neither we can change it, nor we can stop them happening. So that kind of a context is also available. So the decision agents, which are in the middle layer here, these agents, when we deploy them, they can observe the context, they can do their own tasks, and they can make their own estimates and decisions and connect them, give them inward. So from the external 3 levels of context, which are observing, sensing the thing, the decision agents will compute their own things and bring an internal network. Okay, that is something called a dynamic network, which can come in here. That is another another layer of adaptation. So if my decision agent one is saying, I see such and such trend happening here, my decision agent B, second agent is saying, I see something else happening in this. How do we reconcile these two things? And if needed, take a human help and finally come out with what I should do at the given moment of time. I may have multiple options. I can do I can take a strategy A, I can take strategy B, I can take a more defensive strategy. I also stop spending money and I also save money somewhere. Or I can take more offensive strategy saying that I will change, I will buy new product and I try and start selling something. Or I can have a mixed strategy. I can 50% hedge somewhere, 50% to do something else. Okay, these are all going based on the different stakeholders, different risk-taking capabilities. It comes, all the decision science comes into the picture with different levels of complexity again, which we have seen in that original. So now once we bring all these things together, make it work. What and all can be solved? Any type of inventory. What type of industry problems we can solve? Inventory problems. If you are retail, selling in a retail store, how many of that type of dress or shirts or t-shirts or what type of goods need to be there at which place, what will be the demand? This is one of the decisioning problem. That kind of decisioning problems can be solved by this. So we are collecting various pieces of information factors, external factors, feeding them through the insights, creating decisions, creating the network, understanding the static and dynamic contexts of this network, and continue to use the feedback again, continue to feed that. And various things in the advertisement agent. If I wanted to send a message, which message is more effective? How do I send my marketing message? Through a SMS or a WhatsApp message? So for some segment of the customers, a WhatsApp message may be more effective. Some segment it is a text message. Some segment there may be a clickable link. Some customers, when you show that on the internet screen when they are browsing some site, that may be more effective. So to which segment, on what channel you wanted to optimize, this kind of optimization problem. All these typically done by humans, and artificial intelligence, these decision networks, decision platforms, they can enhance the capability of this decision. So it can be applied everywhere. It can be applied in retail, it can be applied in entertainment, it can be applied in BFSI, where I work, where the banks either in the collecting the deposits or the loans and stuff like that. And also in various types of pricing models, demand pricing models, people have to take decisions of what has to be the lower limit, what is the higher limit, at which step you wanted to increase the stuff, decrease the stuff, and stuff like that. So there are various places we can integrate this kind of artificial intelligence based agents, which are coming from various models, into a complex or complicated decisioning scenario and get good results. So finally, I just want to touch upon, because a lot of students are here. So if you want to, I hope you have understood the dynamism or the complexity of this decisioning field. So that is the decision science, decision engineering. So this is where you will have to see there is a data science which is understanding the data, converting the features, identifying the patterns and creating models. And that is the part of the data science. And we need to understand the process, a structured decisioning process, various processes. In that, decision making is also a process. You need to understand the input variables, you have to do the stakeholder analysis, you have to do the risk analysis, you have to use the cost benefit analysis. There are various types of business processes involved in decision making. So combining these two things together, data science, which is understanding data, creating models, tools, Python coding, this is one side of the thing. That alone is not sufficient if you want to work in a decision making scenario. Okay, industrial or business level complex decisions. You need to understand the processes involved in here. Core processes, I have mentioned what they are. Then there are concepts of this psychology and decision sciences. How different people will behave at different kinds of scenarios, what amount of risk taking people will have, how much people will overpay or underpay for certain thing based on the scenario and stuff. That is the whole subject called decision sciences and decision engineering. So putting these skills together, you can develop a career in the decision engineering or decision intelligence. So the decision intelligence platform is what I work, and this is very emerging field of artificial intelligence. So artificial intelligence is an enabler, but decision platforms, decision engineering, decision intelligence. So if you search in the Google decision intelligence, adaptive AI, you will get a lot of resources in this thing. So you can learn these aspects if you want to build a career in this decision science area. So that is what my session is. Then we can actually take few questions. You can ask me questions, technical questions, business questions, anything that is being covered in that session, or even if it is not covered in the session, if it is relating to artificial intelligence and decision.
Any queries from participant side?
So we
Yes,
have
sir.
10 more minutes for the session.
Yeah. Any queries from participant side?
Okay. So I see one question in the chat. Can this be implemented in the field of medicine? Okay. So in the field of medicine, actually, it is much more complex system, right? So typically, it is not a business. It is much more complicated. It can so the framework can be implemented in making any complex decision. So in the medicine field also, this has applicability, but it has more applicability in the other sides of the business. So even in the medical, if for a hospital, if they are looking at, if it is medicine specifically, the treating people, it will have very little application. But when you are running a hospital, yes, there are a lot of business decisions that need to be taken. So decision intelligence framework will come into use if it is running any business, including any medical business, any demand estimation. But if it is exactly treating a patient, normally it is a much more complex process. A professional who has spent most of his life studying medicine will take decisions whether to use a particular therapy or the other. But it can, lot of things can be assisted. So recently there is another story Medicine in the sense it is a pet medicine. So there is a pet owner who owns a dog, and dog is having some symptoms. So he is taking the dog to various veterinary doctors and everywhere, and they are all trying, they are all giving different methods of therapy, but the dog is not getting recovered. So this person actually puts all these symptoms into a chat GPT and says, my dog is having A, B, C, D, E, F, G, H, and then he asks the chat GPT, and chat GPT says, okay, this is what has happened. Okay, this could be the thing. This is how it can be treated. And this person takes this to the veterinary doctor again, taking this, okay, this is what chat GPT is saying. After seeing that, the veteran says, okay, it looks like this. There seems to be a lot of similarity. Let us take this way and try to treat this dog. Okay. And the dog was treated in, okay, for 4, 5, 6 months. He is going around everywhere. Within 3 weeks, it has much better results. So I think in one way, what is happening, this generative AI, because it has the ability to ability to kind of understand a huge, humongous amount of text data. Thereby, it has made some understanding of what are all dogs' symptoms means, and it will be able to assist. So the assistance part, definitely the agent of generative AI, the scenario generation, like this, a new scenario. Okay, this could be like this. So in an economical scenario or a medical scenario, also a scenario can be created using a artificial intelligent agent, but that need to be validated again by a human agent. So that is where it comes together. The both sides of intelligence comes together to help each other and make things better for the world. Hope that makes sense, right? So that is the question for the medicine. And there is another question I see: how would AI help in decision making under risk, especially when available data is scarce? Okay. So that is what is. Again, generative AI comes to the help here. So you have only, for example, there are some scenarios which are known as small data scenarios, low data scenarios, or no data scenarios. Even if it is a automobile engineering team, a crash data. So when something goes and crashes, a car goes and crashes into another speeding car or into a concrete slab or whatever it is, these different crash scenarios, what is the impact, what is the damage done to the car, these things need to be created. So what happens is, in this kind of scenarios, simulation is done. So simulation works in a way that you understand the past patterns and try to diffuse little bit here and there. Generative AI has a lot of potential in generating such scenarios, right? So you can generate synthetic data, you can generate divergent data, you can generate a lot of other types of data using the known. So you can, if you can afford to take a car and take a car manufacturer can create a stress testing scenarios of few scenarios, collect the data from there, and then use generative networks to actually generate it. So basically, how AI can help in no data, low data scenarios, high risk scenarios. If we want to send somebody to Mars or do a Chandrayaan machine, Chandrayaan kind of a project, a lot of simulation. To do these simulations, there is high amount of compute and lot of resources are required. So generative AI has capability to reduce that requirements, and it can generate much better outcomes and scenarios. So thereby it will help creating what you say, a better decision. So for you to make decisions, you need to have the right input parameters, right parameters, right? So you can decide which parameters are very important also. And what is the range, probabilities of those parameters breaching the range, means anomalies getting created. All these scenarios, either anomaly scenarios, real scenarios, hypothetical scenarios, stress scenarios, not only in the in the automobile or physical, even in the markets, markets will have stress scenarios. There is suddenly something will happen, the whole market will start falling. So when such thing happens, what will happen to different stocks or different indices and how they can go? And in that such a stress scenario, how we have to, what kind of things can be done to make the market to have more stability and stuff like that. So in physical systems, in in the data-driven systems, every system has parameters. Those parameters can be forecasted, predicted by the standard AI, but new scenarios can be created by generative AI, and we can use adaptive AI techniques to kind of sense check the thing, because there are certain things which are impossible scenarios that get generated, as I mentioned in the generative. So generative AI, when it comes together with an adaptive AI agents, where the AI agent can sense check and say, is it sensible? Is it there or not? Validate the outcomes. And putting together, if we can generate much more meaningful decisioning environment in various scenarios. So that is the answer for the second question.
Thank you, sir.
Any other questions from anybody else?
Thank you, sir. I thank Prasad Chitta for such a informative session on artificial intelligence in decision making. Now, I request Prasad Chitta to accept virtual memento as a token of love and respect.
Thank you, sir. Thank you very much.
Thank you, Prasad Chitta, sir. My special thanks to Sri Srinivas Ramanujam, sir, Regional Head Academic Interface, TCS, Bangalore, for joining Bytes Expert Series. I also would like to thank all the participants for joining Bytes Expert Series. Thank you one and all.
Thank you very much.